Okay, so I'm starting. My name is Andy Otin Ewuku. You can just call me Andy. I'm a full stack developer. I've been at the back end, front end, and also mobile. So I have experience on all the platforms. And I would say this class is going to be epic. I'm going to dive more into what my brother started last week on software, computers, and all that. So to brush up with what we learned last week, it was all about the hardware, computer, what computer is, and he said your mobile phone that you're holding is a computer. The laptop I'm using is a computer. Anything that's reads an instruction is a computer. So even your calculator is a computer. But then we are not going to dive into the hardware aspect of the um, computer. We are going to look at the software aspect of the computer. So a follow-up topic is computer software. What is computer software? And as you can see in the into brackets, I've written program. So yeah, I'm starting the class. So before I talk about software, let's talk about program. A program is an instruction that tells a computer what to do. So you can just write sit down or stand up, and anytime you call that command or that program, it tells the computer to do that. So you can write a program to say shut down, and the computer will shut down, boot up, and the computer will boot up. And anytime you call that program, it runs, and then the computer follows that instruction. So a program is just a set of instruction or an instruction that when you run, the computer listens to it, understands it, and run. Then we come to software. Software comprises of the entire set of programs. So software is like a collection or a group of programs that runs together to perform certain tasks or functions. So it's clearly written here. Software comprises of it's comprises the entire set of programs, procedures, and routine associated with the operations of the computer. So it's a collection, not just a single program or a script, or let me say, it's not just a sit down um, command. It's comprised of sit down, stand up, um, go and walk and come back, come and sit down. It's all that into together, and we call it a software. So we'll dive deeper. So a set of instructions that directs a computer's hardware to perform tasks to call a program. It's called a program or a software program. So for instance, if I want to shut this PC down, I just go to the right corner button there and I just click shut down. That shut down goes to call a whole lot of softwares, instructions to shut the PC down. And that is what we call a software or a program. So let's dive deeper. Um, so there are types of softwares, and we are not going to tackle all of them. Yeah, we are going to tackle a particular category of softwares. Now we have system softwares. The system programs that control and manage the basic operations of a computer are generally referred to as system software. So um, when you open your phone or your hardware, your computer, there's an OS that runs on it. Operating system, sorry for using the short terms. Operating system, always called the OS. So Windows application, Ubuntu, Mac, when you on your phone you have Android, you have MacBook and all those things. The system software that allows all other softwares to run on it. That's what we call the system software. And that one, we have organization, big organizations have, it's like a legacy system. Big organizations have sat down to write those programs to listen to certain hardwares. So we are not going to dive into this because it's more, let me say, you can't build this from scratch. It's already done. And when you build it, no one will use it because we already have Windows, Ubuntu, macOS doing what they need to do. So we don't need you to come and add any OS to it. But you can dive into it if you want. It's a good venture. Of course, Bill Gates is rich, so if you try and build maybe a DOS instead of Windows, maybe you might make money. So we also have utility softwares which perform a specialized task that enhances the computer's operation and safeguard data. Examples of these utility programs are antivirus scanners and backing up programs. So for instance, your antivirus software that runs and makes sure that the hardware and the software are not compromised by any other malicious software. They are all called utility softwares. And at this point, this is my favorite section. And this is where we are going to dive deeper, because this is what the class is mainly about. We are going to teach you how to build application softwares. Now, these are programs that make a computer useful for everyday tasks and are known as application softwares. These are the programs that people normally spend most of their time running on their computers. Example is your Microsoft Word that you use in creating your documents for your project work, word processing, Adobe for doing your Photoshops, designing your photos and all that. Also, the social media applications such as the Facebook, Twitter, WhatsApp, all of these are application softwares and you use them every single day. Your email application that is on your PC that you use in sending emails, your web browser as well. But then sometimes you can, there are some applications that fall in between the utility and the application software. Your web browser, someone can build a web browser from scratch and use it personally. So someone will also categorize a web browser as a utility software, but then it can also be an application software. Gaming programs that you have on your phone that you always click on. Yeah. So we are going to dive deeper, and this is where we are all going to be building exciting applications after this class and beyond. So another area that you have to take into consideration is how computers store data. Programming is all about storing data at one point and retrieving it at another point. So you need to understand how the computer stores data. So computer data is stored in the memory. All the data that is stored in the computer is converted to sequences of zeros and ones. So even the display that I'm showing here, every bit of the screen is displayed as 0 and 1. And that's how the computer stores information and displays it. So we are going to dive deeper into this one too, but then this is the basic understanding of how computers store data, and I try to make it as simple as possible and not make it too complex, because when you want to dive into this a whole lot, so I've made it simple for you. It's a computer's memory is divided into tiny storage locations known as a byte, and each byte contains is divided into 8 smaller storage locations known as bits. And don't even worry yourself with the bits. Bits is just a representation of 0 and 1. So it's either 0 or 1. And some people also call it true or false, or negative or positive. But I will stick to the 0 and 1. So a bit is either 0 or 1, or off or on. So basically that's it. And that's the basic way computers store information. When a piece of data is stored in a byte, the computer sets the 8 bits to an off or on pattern that represents the data. So this one, I know it's a big vague, but just have a picture in your mind that behind the scene, every data that is stored on the PC and displayed is just zeros and ones. Even what you are seeing right now is zeros and ones, tiny bits that is displaying. Yes. So a sample data storage of a data. So for the computer to store the number 77, it needs to convert it to a binary digits before storing it. So although you are seeing all these readable things, the computer doesn't understand what we the humans understand. All it does is it stores zeros and ones, and it also displays that zeros and ones. So the 77 that you are storing and data on retrieving, which is someone's age, it's not stored that way for the computer, but for you, you think it's stored that way. And behind the scene, this is how it is stored. The dark screen here, this is how it is stored. And you don't need to understand this. We have how do you call it? Programming languages that has come and made our work easier. In the olden days, this is how people used to code. If they want to write 77 somewhere, this is what they write. Zeros, they have to know the binaries of head. But we are in the era where we have smart programming tech stacks, and you'll be introduced to all of them. And storing data is as easy as possible. So it's not going to be binaries like this. So all alphabets and special characters like the ones you are seeing here have their unique numbers called the ASCII numbers. You can go and read on them, which don't change. It's a lot. So they don't change. They are forever the same on every country and every computer. Unlike we human beings, that when you go to German, they speak German language. When you go to France, they speak French. No, it's not like that. The whole world, all computers have one language, and that is bits, zeros and ones. And it's called ASCII, and it doesn't change. When all the bits in the bytes are set to 0, it means it's off. And then when the value is set to, this one I've already said it. And when all the bits in a byte are set to 1, it turns on. Yeah, so I think I've repeated myself here. The large values that can be stored in a byte is 1 to 225. So this is the largest value that can be stored in a computer. The limit exists because there are only 8 bits in a byte. So this is the way computers store each information, and it can't exceed. So it has to be within this set of numbers. Every single character in the world or color or anything has to be stored within this set of bytes. So for example, yep.
Sorry, can you go back?
Yep.
Yeah. So sorry, my name is Amankwa.
Oh yeah.
So let me also help you right here. As we said, we all went to school. We learned something called cell, which is like a basic unit block of a living organism. So every organism has got a basic block of it. So when we come to computers also, when we are storing data, we store it in the memory. And when we go to the memory also, the memory has also got a basic unit block, which is called the bytes. And within this particular byte, it has got compartments, which is 8 compartments. And each compartment is called a bit. So all the bytes or the basic unit block of a memory, which is called a byte, stores the data. So, and it's 1 byte is enough to store, let's say, a particular character, let's say 77. So this 77, when we are converted it to base 2, that's when 2 divides, you know, when in mathematics, number numerals, base 2 numerals, you can convert it to base 2, and you're going to get 100111101, which means the zeros, we have 3 zeros in here, which are not being filled. So this particular number can still be stored in the bytes compartment. But then when we have, let's say 255, when you convert 255 base 2, you are going to get 111. That's 11111 up to 8. So all the zeros are now going to be full, like all the particular switches are going to be turned on to 1111, and that is what we call the limit. That's the largest value. The moment all the zeros are turned on, it means the byte is full now. You understand? So that's how come the 255 is the largest value. But then if we have extra data, which is more than the 255, let's say if you want to store 300, what are you going to do? How is the computer going to store this particular data? You understand? So every character, every number, everything, every data that the computer stores, it's into the bytes. But then if you have more bytes, it means you have a lot of data, or you have a lot of memory to store your data. So some people have got, let's say, 2 megabytes. Some people have got 32 gig. So in the 32 gig, you can divide it and know the number of bytes you have in your memory that can store the data. So that's how come we got a 255 being the largest value that a byte can store, because for the 255, when you convert it to base 2, you are going to get all the zeros being turned to 1, and that is it. And we know we are dealing with binary numerals, which is only zeros and ones. So the moment is all the zeros are turned to 1, that's it, is filled. You can no more go to the 9th value, because it stores up to only 8 digits or 8 bits. So you can't add another 1 to it, making it 9. So that's how come 255 is the biggest and the largest value for a byte. So I think Andy can move on.
Thank you, sir. I hope we are clear. If you are not, we can still come back when it's time for questions. Yeah.
Okay, Michael, I do raise his hand.
Okay, so Michael.
Okay, I just want to know, with the explanation, with the bytes, you said, let's say there's over there, the 77 converted to base 2. We have, when I count, I have 7 numbers, but unless you said 8, or
yes,
right?
Yeah, exactly. So
in that case, it has to be stored here.
In that case, the extra value is 0, but then since the value which is 0 after the number or before the number is not counted, so we have only 7 values over here, and this particular value can be stored in the byte, which has 8 compartments, and it's okay to be stored over there. There's no way.
Okay.
If you get
so it will have a leading 0, right?
Yes, exactly.
Yeah.
Okay. Thank you.
I hope you are answered.
Yes, please.
You understand now? Okay.
So someone may ask, how do we store the character A into bytes? That's how can we got the ASCII numbers. So all the computers, the processors that we have, Intel, AMD, all those who design the processors, they've made it in such a way that every character that is not a number can be converted or has a unique code, which is called the ASCII number. So when you take capital A, for instance, the unique code for capital A is 65. So this 65 will now be converted to a binary digit and now be stored into the bytes. So that's how come we got that. So all the hash, full stop, @ sign, the $sign, all of them has got ASCII numbers, which you don't need to know. They are there. They are already there. You can search on them online.
Yeah. So if you want to understand the basic storage of data, you can just Google ASCII and you get all the information there. But it's good you know. But then in the real world, when you're developing a software, you will not be more like focused on the binary and how the computer is storing. All you just have to know is the data type and all that, and we'll jump into that one. So from what my colleague said, other types of data, so we have music, we have pictures, and so like he said, here the characters here have their own unique this thing in ASCII. So the same way we have pictures, these images are composed of tiny dots of colors known as pixels. So each pixel on an image is converted into a numeric code. A numeric code, take note of that, that represents a pixel of a color. The numeric code is stored in a memory as a binary number. And music is also a form of data, and it's a digital song that is also broken into small pieces known as samples. And each sample is converted into a binary number, which can be stored in memory. So that's how come you're able to log on to your phone, and the music someone sent to you on WhatsApp, you can easily play. The computer is storing it for you, so that anytime you wake up, you can. Else, if the computer doesn't have a way of remembering all this information and data, you will not be able to access your phone and have the previous information. And banks will not be able to remember your balance. And imagine you've worked so hard and you have about $1 billion in your account, and the following day you go and they tell you the computer has forgotten your balance. So that's the importance of data storage. Data is very important and is the core of every programming or every software. So
okay. Can I
I'm leaving.
something else?
Okay.
Yeah, so with the pictures, we have different types of data. You know how you be wondering how computers store your pictures, how computers store your music, like your files, everything. So with the pictures also, pictures has also got the basic unit block, which is called pixels. And this pixel is converted to 1 or 0, which is a binary number, and being stored in the computer memory. The same way music also has the basic unit block, which is called samples. And these samples can also be converted to zeros and ones, which also stored in the memory. We have different types of data, like the document and other things. They are also being broken down into their basic unit block and now stored as binary number. We all have digital, we've heard of digital television and all those things, how the data is being transmitted to it. For us, we are seeing the videos and the pictures and everything, but then how the TV is translating everything, they are all zeros and ones. That's how we got a digital TV. That's how it is being transmitted. It's being transmitted as zeros and ones, and we see the pictures, small pixels. So the small pixels come together to form the bigger picture, and the moving motions of the pictures now forms the videos, and now we can see them. But behind everything, they are all binary numbers, that is zeros and ones. That's what a computer understands. Computer only understands zeros and ones. Computer doesn't understand what we've written here, other types of data, other anything. The computer doesn't understand anything. For the computer to understand, he understands the zeros and ones. So you convert the zero, the O to a binary number, T to a binary number, H to a binary number, and you store everything. And that's what a computer understands. So normally what we've got is we've got something called assembler and also something called compilers. These are terms. So what we normally do is we write programs, higher programs like writing over here, Microsoft Excel and everything. Then there's something on the processor called the compiler. It will now take everything that you've written, that you to the human being, you can see and understand. Like I've written here, pictures. I understand pictures, but the computer doesn't understand the picture. So the computer will now take the picture, the compiler will take the picture and now convert everything into the binary number so that the computer can understand and store this particular data. So there's an intermediate over here. So there's someone who is compiling everything to the computer as a machine language. The zeros and ones are termed as machine language. That's why we have other languages, but the zeros or the binary numbers are termed as machine language, and that's what the machine understands. Even your mobile phones even understand only zeros and ones. Thank you.
Thank you, sir. So to add to what he just said, normally you hear, oh, me, I program in PHP, I program in Laravel, I program in Ruby on Rails, I program in Golang and all that. These are all programming languages that the computer understand, but then it's not the basic. It is like I've forgotten the name. I need help here, but they are advanced languages. But the core, the basic is they all translate or compile into zeros and ones. So no matter the language you are writing, the programming language you are writing, if the computer is supposed to understand your instructions and then perform that action, that withdrawal you want the instruction to do when you click the button, behind the scene at the end of the day, it all goes down to zeros and ones, and then the action is taken. The same thing if you want to display someone's photo, it's the same thing. Everything goes and comes in zeros and ones, but you don't see it. And you can dive deeper and understand more, but we just wanted you to have this core understanding on how data is stored and how data is understood by the computer. So I'm leaving this question to you guys. I'm not going to answer it. It said, what if you need to store a number larger than 255? I think my boss almost said it, but you should go and get it yourself. I'm giving you this question so that you can understand it yourself. If I tell you, I'm not giving you homework. So this is your homework. And what is digital data? You can go and read on that. And maybe if you have any question, you can throw it on the page, and then we can follow up and answer it for you. So yes, we'll be talking about data. But data also have types. And just like in the real world, we have water, we have sand, we have air, we have fire. They all have a way to be contained. You can't go and pour water in a basket, and you can't go and pour you can't go and pour certain content in certain contents. They won't work. They won't hold. It's the same way data is stored, and we have a reason why we store data in those forms or in those types. So data type is a classification of data which tells the compiler or the interpreter how the programmer intends to use this data. So for instance, you can't use a Boolean true or false to store someone's balance. Else the whole world, everyone's balance will be true and false. So it has to be a value, and that value is called integer or decimal or double. So you dive deeper when you enter into programming itself. You see every programming language and the way you declare these variables or these data to be stored. So the basic thing I just gave is, so we have integers, we have real, we have strings. So if you want to store someone's name, you can't go and write 101234. Who is that person? So you have to write the person name as Andy, and that data has to be stored in a string format. And Boolean, if the person is married, you can just say true or false, and so it's married, and just states as true or false. A single, true or false. Then just store it wherever you have to store it. So anytime the Boolean comes, it's either true or false. So basically, data has types. You can't just store any data to represent any information. It has to be of a type for the computer to understand. And when it comes to processing, for instance, there's some data that you can operate on. For instance, if I want to withdraw 500 cedis from my 1,000 cedis in my account, the computer has to remember that I withdrew 500 cedis and it's left with 1,000 cedis. So that value has to be in a number form so that we can subtract. It can't be in a Boolean, true or false. You can't do anything with that. So these bytes represent the data that can be interpreted as representing values that we understand. This data comes in different forms. For example, your name, like I said, it should be in a string. Your age should be in an integer. and your money should be in decimals, because the 50 pesos dot 50 pesos too is accountable for, so it should be in decimals or doubles. So I'm
Andy.
also going to give you, yes.
Yeah, sorry, can I also chip in something?
Yeah, sure.
Yeah, so as my senior colleague said, over here too, we have, you want to deal with data. You want to store data to the computer. You want the computer to understand what you want to do. Assume you want to store, let's say, someone's bank balance, as he said. You need to choose the data type. You need to tell the computer that, okay, fine, this data that I'm bringing to you, it is not characters, or it is not alphabets, but rather it is integer, a whole number, or let's say a decimal. So that's how come we have something called the data types. You need to tell the computer that, hey, this data I'm giving to you, it is either true or false, and not numbers. So you need to define and let the computer understand that this is your data type. So if you store it as a number for you, or if you store it as a string. When I say string, that's a group of characters, or let's say alphabets or numbers or anything. Anything can be a string. So that's how come we have the data types. So let's say your name is, let's say, Joe or Andy. When we take Andy, we have a group of characters or a group of alphabets which comes together to form Andy. And these characters, when they come together to form Andy, we call it a string. Sorry, a string. But if it is just one, we call it character. But if there are a lot of characters, we call them a string. And we all know integers. You also know integers. A number can be, let's say, 2 or 3 or -1. They are all integers. If you have, say, something like 2.5, it's no more an integer. You cannot call it a decimal, or we have something called float, or we have something called double. They are all advanced things that we will be learning later. So these are the data types. We have a lot of data types, and every programming language has got the data types, but we have some common ones that we are going to learn. But when you delve into the other programming languages, they will teach you their own data types that they have. But now we are going to learn the common ones that are common to every programming language. Okay, thank you.
Thank you, sir. So I'm going to the next. So data storage and data types. Let's classify the following data into their following types. So from what my colleague said, John Smith will be stored as what? I won't say it. You can screenshot this and then answer it on the page. The ones
Andy,
that you were wrong.
I think
I should answer it. Okay.
Yeah. So let them answer.
Okay. So if anyone has an idea, you can just come up, or I should answer it and we should go fast. You can just unmute and just say it. If you are wrong, no worries. We can just correct you. But I just want to get your.
So John Smith is a string. 36
yes.
is an integer. 162.4 is a float, or it's a decimal number. True is a boolean.
Who is asking? Is it George?
No, Dazi.
No, that's Dazi. Dazi, continue.
Yeah.
Continue.
So D is a character, but for SO, that is so, I do not know, but probably it may be a string. It's vast of by Mr.
Oh, okay.
And then,
well done.
And then the next one, smith@gmail.com. That one too, I do not know. The next one, 0.0 is a decimal.
Okay.
Or we can say it's a null number. All right.
Okay.
Okay. Yeah.
Anyone else?
Another person should try.
Well done, well done, well done. That's it.
Who is also trying?
You almost had it all. Okay, so because of the noisy background of some people, I think we just have to continue, boss. Just if you give me the green light, I'll just mention. Okay, so with Smith, John Smith, it's a string because their individual characters combined together, and it's a string. 36 can be an age of someone, and it's a whole number, as you can see. So it's an integer. It will be stored as an integer. 162.4 will be stored as a float, decimal, or a boolean. Did I say boolean? Sorry, a float or decimal.
Or double.
Or double. Yeah, that's the word I wanted to use. True. As you can see here, it depends. If you put quotes around it, it will be a string. But true, like this, can be stored as a boolean, or will be stored as a boolean. Yeah. So true or false is stored as a boolean. And the D.
Sorry.
Okay.
Boolean may seem new to some people, but then Boolean is an example of the data types that is used for storing only true or false. That's it. Or false. So it's like true stands for 1, false stands for 0. So it's something that is similar to the binary numerals 1 and 0. Yeah. So it can only be true or false. There's no way I'm going to have intermediate like I don't know or I'm confused. It can be either true or false, and that's all. So it's a type, it's an example of the data types. So we call it.
Yeah, thank you. But in the real world, sometimes some people prefer to store this as a string. I don't know why they do that, but you should just store it as a boolean if you are going to just do true or false.
Yeah, exactly.
And we have D. D is a character, and a combination of this is what we have here. It can be stored as a string here. So this is just a character. And this are a combination of two characters. So it should be stored as a string. A string.
Yes.
The email here too is a combination of characters. 1, 2, 3, 4, 5. It's a whole lot. So it will be stored as a string, just like the way we stored
plus punctuation,
John Smith.
Plus special characters like @sign. All of them together. Even if there was, let's say, Smith25@gmail.com, it's like a group of characters. Yes. A group of characters plus other special punctuation marks and other things. They all come together. They still form a string.
Yes. And then the last one, 0.0, it will be stored as a float, decimal, or a double.
Yes.
And these are all the data types that we have here.
So let me ask this question. What about what data type can we use to store -5? What data type can we use to store -5?
Are you asking me or you're asking the class?
I'm asking the class.
Integer.
Okay.
Yeah.
Yeah, integer.
That's correct.
Okay. Thank you. All right. So we've already said this, but then we are just highlighting on it again if someone didn't understand. So integer, which is a whole number. So this is a whole number. Ignore the commas. In the real world, when you are storing the data, there will not be any commas. But when you are displaying to the user, there are some formats. Okay, sorry, these are separate numbers. Yeah. When I saw the comments, I was confused. Okay, so -5, 0, 1, 2, 3, or 123, it's an integer. There's no .0 or anything. So these are whole numbers, they are integer. And such values like this are used to store the user information, user's age, user's bank account number, bank accounts details and all that. Yeah. So that's it. Floating point or floats. So this is example of a float that I just said, or a fraction. It can also be called as a decimal. Yeah. So
Yeah.
decimal. So or what's double. Yes, double. So anything with the point in between dots with a lot of things like this, yeah, it falls under this section. And string. Hello world is it's an example. Your name, everything you see here, these characters, all this, if you want to store it somewhere, it will be stored as a string. Boolean is either true or false, 1 or 0.
Okay,
so,
chip in something here.
Yeah.
I have two things over here. So when you see the hello world, what's the difference between the hello world and the other ones? You see the hello world is in quotes.
Yes.
But the others, all the others are not in quotes. The moment I will store true in quotes, what will be the data type? Or the moment I will put true in a quotes, what will be the data type?
Let me chip in. So all the strings, yes.
Okay,
it's a string. So all strings are noted to have quotes around them. It's either a single quote or a double quote.
Yes.
In programming, that's how it is. So that's why I said, oh, you might say, oh, but these people told us that anytime I see true or false, it's Boolean. Yes, but some people store true and false as string for some reason. So you see someone's code or someone's written an instruction and the true and false are in string, but it's a wrong way of coding though. You just have to let your Boolean be in Boolean. Yeah. So you see some people write true with double quotes inside. The moment you see it, it's not a Boolean. The data type is a string. So just note that even this, if you see this or this, and the moment you see the double quote or single quote around it, it's no more considered as an integer or a float. It is a string. So always, all strings are noted with their quotes around them. I hope we are clear.
Yeah, and also we talk of the floating, the double, the decimal, like everything. Probably when we go advanced, you know when to use double, when to use float, and when to use decimal. We have something called precision. Precision is like after the decimal points. The number of digits after the decimal point determines which data type that we can use. But then normally we can use any of them. But then when they go to the memory, and we talk of storing data to the memory, something like 87.5, the precision or the number of digits after the decimal is just only 1. So in this case, I don't need a float. A float is used for storing, let's say, decimal values that have got a lot of precision of values. Like let's say 3.141534, like 10 times 10 raised to the power negative 25 or something. You see the number of precisions after the decimal will be a lot. And in this case, you can't go and store that value into a double in the memory. If you take a double in the memory, it has got a limit for the number of precisions. But when you take a float has got a lot of decimal precisions that it can store. When you take decimal, for instance, it can also store some kind of precision. But then we starting the programming, we'll be using either the float or the double or any of them. We can use any of them and we go away. But then when you go advanced and you are trying to do correct data types, you need to know which data type to use for any decimal value. But then for now, we will just use any of them.
Yes, and for those of you who will be working more on the back end or focusing on the back end, you need to take keen interest in when to store a decimal and a float and this thing. For instance, if you are storing information concerning health and the person's BP is something point something point something point something, I don't want to give a wrong figure. I don't know how BP is stored, but then there's a decimal, 4 places decimal for that person's health distance, and then you store it in a wrong precision and it cuts that information off. You might, maybe there's a drug that has to be given to that person based on the value that you are displaying, and you are not displaying the accurate value. You could cause harm to that person, or you could something can happen. Maybe it's a building, and based on the calculation they have to use certain cement blocks or certain this thing. So this information you are seeing here is very vital. For instance, also someone's account balance. If always you are storing it in a wrong precision and then it is cutting off certain digits from the person's balance over a period of time, that small digits that were cut off, when you add them, it's huge money, and that person can fine the bank if he finds out. So storing information is very important, and it's very key to know when to store which type of information, how.
Yes. So just adding small to it before you move to the next slide. With what Andy said, assuming you are storing the balance as he said, and the balance, a balance can be, let's say, 20 cedis, 50 pesos, so it can be 20.5. And now you as a programmer, you've been instructed to write a program that will store the balance and do some calculations on it and add an interest rate, blah, 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 and calculate some loan interest. Then you storing the balance, you've defined the data type for that balance to be an integer, and you're storing 20.5. What do you think will be the value that will be stored if I'm using integer to accept 20.5? What do you think the computer will store? Hello?
Hello?
Who knows?
Maybe
yes,
you
Mike.
have to come.
Please
Okay.
come in.
Come again.
No, the question again.
So the question is, you've been instructed to write a program and to store the let's say the account balance of someone's account, and the account balance is 20 cedis, 50 pesos. So let's say it's 20.5. And instead of you to define the correct data type, you use integer to define the data type for the account balance. So you're using integer to store 20.5. So at the end of the day, what do you think will be the value that will be stored to that particular integer? Because the integer accepts only whole numbers, but there you are putting in 20.5. So what do you think will be the actual value that will be stored?
20.
20, exactly. So what the computer will do is, since you say it's an integer, okay, fine, I'll just take only the integer part and leave the decimal part, because for data type as integer, I can only take integers and the decimal part will be lost. So in this case, you are killing the person. So the person will bring 20 cedis, 50 pesos, and you are storing 20. The next day he will come, he will bring you 30 cedis, 50 pesos, you store only 30. And at the end of the month, he wants his total calculation. All the 50 pesos will be lost, and it will be like a hell. So you understand? So programmers also, we are like doctors. Just a single mistake can kill the whole business. So
Yes.
you make sure you put everything like in the correct order, because just a single mistake can cause a serious wrong calculation in mixing drugs, and it can go and kill someone simple.
Yes.
So I think we can move on to the next slide.
Yeah, thank you. So another favorite section.
I think that's the last part.
Yes.
Yeah, left it.
Variables are used. Okay. You said what?
We are left with 12 minutes.
Okay, so variables are used to store information to be referenced and manipulated in a computer program. They also provide, I'll explain, they also provide a way of labeling data with a descriptive name. So our programs can be understood more clearly by the reader and ourselves. Also, it's helpful to think of a variable as containers that hold information. Their sole purpose is to label and store data in memory. This data can then be used throughout your program. So variables are, in the real world, a bottle. It can be a bottle, it can be a basket, it can be anything you have to think of. But then that variable has to be of a type. So, and we do that because if you want to store a number called 13, we have to store, you want to manipulate the number called 13, which is someone's age. You can't just start manipulating. You have to put it in a label called age, or maybe customer age, or building age, something. So when you are coding, you can just write, okay, so customer age should display here. Then you just put that value there to display. So it's more of like the programming language, the software way of picking their values and displaying them. And it's also a way of helping you, the programmer or the developer, to understand that, okay, so when the database or when the back end runs, or when something is the program is running, the age of the person is stored in this section and it is displayed here. So we can have a variable called phone number, a variable called username, a variable called full name, password, and all that. And when you dive deeper, that's how cybersecurity, all those people are able to do fish out and get to pick people's password and all those things. That one is all something different in networking and cybersecurity. So your variable naming is as important as writing your code. Now you can't store someone's age as username, because when you are displaying the age as username somewhere and another programmer picks it up and is working with it, you consider that username as username. Or sometimes when the mistake we do when we start programming is you start with your pet name. You can just write Rocky, var Rocky equals, then you just put something there. Meanwhile, the Rocky is someone the age of something. I don't know if I've explained it further, but variables are just a way of containing a data type, displaying or manipulating it, and also labeling something. And it seems all this is vague, but when you start programming and you revisit this particular page, you understand what we are saying. But then in general, variables are ways you can label your data type and also manipulate it and display it to the screen or user. Okay. I don't know if my colleague has any.
So we've talked of storing data to the memory, and we should always have in mind that the memory is somewhere inside the hardware where we cannot go there to store our data. Even in the memory, it has got names for every location, which is called registers, but then we are not going to go there. But for you, the user, to be able to store your data somewhere and pick it anytime you need it, you need to put your data into the memory. But then we are going to name that particular section where we are storing our data as a variable. So when we talk of variables are like containers. So it is not the container which is the data, but then the variable is just the container that contains our data. So anytime that we will say, let's say we have a section of the memory, and we call it, let's say, first name. The first name, we see it as a container in the memory that is storing, let's say, Joe, which is the first name of someone. So anytime we say variables are just containers that will contain the data that we will be storing into the memory. But we can't go inside the memory and say, okay, store this at register A01234, which we cannot remember always. So we, to the programmers, we have something called the variables, which is like just naming, giving a name to that particular segment of the memory. And we say that, okay, fine, store this data here, and I will call it first name. So anytime I call the first name in my program, I know that I'm retrieving Joe from there because I've stored Joe in that particular container or that particular section of the memory. So that's how we have the variables.
Yeah, and when we start the topic of database, you understand more when it comes to variables. It's the same concept we use in database, storing data inside tables and all that, and labeling them and fetching them and mapping them. I wish I could just open a notes pad somewhere and then just show you how a simple way of declaring variables. But I think when we start the programming itself, we will talk about variables again.
So I think I'll move on to the next slide. If you have
yeah. So this is your assignment. Oh no, assigning values
so let me
variables.
Go
sorry.
to this one, and probably can go to the next one. So when you are naming variables, as he rightly said, you need to make sure the names of the variables are meaningful, so that anytime you take your code, you will see that, okay, fine, this is first name, this is account balance, this is, let's say, this is interest rate. So anytime you see it, it's like we have named all the containers which will store all your data. So they should all be meaningful. And you try your best to make sure that the name you assign your variable is accurately descriptive. So you should be able to describe whatever that you are doing. So let's say first name, as I will always use first name. When you hear first name, everybody knows first name. When you hear surname, everybody knows surname. When you hear of last name, everybody knows last name. So it should be descriptive of whatever that you are doing, so that anytime you take it, or even when someone takes your code, you'll be able to understand the names that you did in your code. And you said, okay, fine, this first name at least is storing first name actually. Surname, I know that it's storing surname. And whenever you want to put data into your container that you define, so we'll be using variable and container interchangeably. They are all the same thing. So if you want to put data into it, what you normally do is you write the, let's say, first name equal to, then the data comes. So the equal to is rather putting the data into the container. So just the equal to do the magic. Just say first name equal to Awuku, and Awuku will put that data in first. So anytime I call first name from the computer or from my program, I'm referring to Awuku rather. So I will deal with first name, but then inside the first name, that's the container. There's Awuku inside that container. And that's it. So I think I'll go to the next slide and we see examples.
Okay, so over here you can see that we are declaring a string, and the first name is equal to Joe, and you should note that there's a double quote here. So this is what's making this variable a string, and it depends on the programming language you're writing in. There are some programming languages are strongly strongly typed, so you have to specify string first name equals this. But if you are coding in Ruby or PHP, you just have to bring your $ sign and then write this equals this, and it will just represent a string. The same way interest rates, since it is this way, this thing is declared as what, a double or a float.
So I think
I'll call it a decimal.
Over here, the intention was not to show the data type over here. The intention was to show only the variables and how they are being named and how we can put data into that particular variable. So if you take these things, some people name their variables. We have the camel case. The camel case, that is the first one. Let's say first name. The small f, the first letter, which is f, will be small, and the name will be capital. So when you take interest rate, the I is small, the rate will be capital. Is first character, which is I, will be small, then the other ones will be capital letters. So that's how some people name it, like how some people, the way they name their variables. And some people also, they will say that, okay, fine, for the first name, I don't need to add everything together. So I will say, okay, first underscore name, so that it will be readable for me. So any of them can go, any of them, anyhow you want to name your variables, I think they are okay. And these are just examples. So we have the camel case, and we also have the underscores.
Thank you. So yeah, as my colleague said, there are a lot of naming patterns aside the camel case and then the underscores, but then these are the most used ones so far. And when you enter into a programming culture, when I say programming culture, I mean when you are coding with a group of people on a software, maybe you are building a social media application for a group of people, they always have a culture, a way of coding, and you can't just go and start naming variables anyhow. So to add to what my brother said, you notice, sometimes they'll not even tell you, but you notice that all variables are being named in this format. The first starts with a small character, and if there's another set of name, it starts with this, and that's what we call camel case. Camel case, you know, camel, they have their back is some way, like they have a hunchback somewhere. So that's what they're trying to say here. And the snake case, you know, snakes are zigzag, like they go zigzag. So as you can see, it's zigzag like this. So basically that's why they give it a name, snake. So it goes like this, it goes like this. But the other coding variable conventions that is used. So if you don't see this or this in certain code structure, when you join a particular group of people coding, just look at the pattern and follow, and it will make your coding nice and also easy to read. If you've not coded before and you've seen people coding, you see a lot of gibberish lines being written, like a whole lot of lines, and you ask yourself, how do they understand? It's just a coding convention and a culture they've developed, so you understand everything. So as we go forward, you understand bit by bit how all these comes together. So basically, that's it for me here on variables. Assigning data types to variables. Assignments for class to assign the data type to the previous variables. See the example below when doing it in Java. Yeah. So
I think can you check the slide from the docs that you shared with me? I think you did the change later.
Okay.
Yeah, so I think you can go to the slide.
The slide. Okay.
Yeah.
This one. Okay.
Cool.
So as you can see, like I said, there are some programming languages that are strictly typed or strongly typed. And strongly typed means that when you declare that variable as a string, when you are declaring that variable, you have to specify the type of content or the type of data it should take. So when you declare string first name and you pass a value that is not a string, there's usually a line that will be underlined and the program will not run. It will not run until you fix that issue. So for instance, if you write string first name and you put 1 or 0 there without double quotes, it will not run and it will not understand. The computer will not understand. The same way you write float and you put Joe there with a string, it will not understand. These are for strongly typed programming language such as Java that which language? C++, and C# and all those programming language. There are other programming language too. You don't need to specify the type, but then sometimes when you pass the first variable you pass into it declares it already, and you can't put another data type inside it. And Node is fan of doing that. Did I say Node? Yeah, Node. So Node has var and let. When you pass the value to it, you can't change the value again. It just has to flow through it. Yeah. So I don't know at this point if anyone has question or is confused somewhere, or my boss, my colleague, if you have any additions to this, you can.
Okay, cool. So if you have any additions, we have James over here. We have Ata also here. We have other colleagues over here.
Oh yes, I forgot to acknowledge my colleagues. My learned colleagues, if you have any additions,
you can ask your questions.
Okay, I want to ask a question.
Okay, great.
All right. So let's say you have a number, okay, but you want to, let's say, less than 5. Okay, using the less than sign. So less than 5, or let's say greater than 12 or something like. So how do you categorize such a data type?
Come again.
I'm saying that you want to store numbers, okay, but it is something like less than 5, less or equal to 10, greater than 5. How do we categorize this kind of, numbers?
Numbers. Okay. Wait,
okay. So I don't know.
Answer.
Okay. Maybe you are coming on board, so you just start.
James.
Okay. So should I answer or someone is?
I think James is. You can proceed.
Oh, James, if you want to say it, yeah. James.
And they can proceed.
Okay. So
James is back. Sorry, James is back.
Yeah, sorry, I didn't get the question. Sorry.
So
you can proceed though.
His question is, if you have numbers, like if you have the numbers that are less than 5 or numbers that are greater than 10, and let's say in between, how do you define their data types? That is his question.
They are numbers, right?
Yes.
And are they like raw numbers? Are those numbers allowed to have floating? Are they allowed to be floating point numbers? Yeah, they should have decimals, maybe two dot something. Are those allowed in his numbers? Yeah, sorry.
What I'm trying to say, let's say you want to store a data, okay, and then the numbers you want, let's say, less than 5. You want to store the number less than 5. You are using the less than character.
The less than symbol.
Okay. Yes, the less than symbol. So less than 5, or let's say greater than, or less or equal to. So I want to know how you categorize these kind of numbers. Whether they are numbers, they are strange, or I don't know how such numbers can be.
Later we will be entering into operators and all that.
Okay.
But then if you are storing, if you are storing a number, or if you are storing a value, all you have to, the first question you have to ask yourself, what data type is this? Is it a string? Is it a Boolean? Is it going to have decimal places? Is it going to have that? So the reason why my learned colleague was asking, because it's a range, you were saying less than 5. So in between 1 to 5, you can have 1.5, you can have 2.5. They are all between 1 and 5. So he has dived deeper to ask, will it have those values? If it's going to have those values, then it's going to be stored in a double or decimal or floating data type. But then if it's going to be whole numbers 1, 2, 3 up to 5, then it's going to be stored in an integer. The same way the ones greater than 5 is also going to be stored in an integer. But then what you do to differentiate which variable it should enter is what we call the operators. The operators, we have the less than, we have the greater than, we have the equal to or less or equal to, and we will dive into that in our next session. We'll be teaching you how to use operators, when to use them, and why we use them. We also teach you the if statements, the looping, and all that when we dive into programming. So it's all going to be covered, but I hope I've answered your question.
Hello, is your question answered?
Hello.
Hello. Yes, my question is answered.
Okay, great.
Okay, thank you.
Any more questions? We have let me see. Samuel Osebonsu. Any question? Okay.
So I know.
Okay, great. Andy, you can proceed. I think there are no questions. Michael.
Yeah.
So
yeah. So I think this is the last meeting for the year. I stand to be corrected, but next year we start for Vim. I'd like to use this opportunity to let you know that code is like humor. When you have to explain it, it's bad, but then behind the scene, it's good. And use this opportunity to get all you need, especially a computer. Don't go and use all your money to chew the chicken and the goods. Save small and buy some small laptop or PC. Because when we start going hard and start coding, programming, what will sadden our hearts is someone coming to say, I don't have a computer, or I don't have this or that. That's why we've started this, to whet your appetite. And you use the holiday period and all the gifts that you'll be receiving. If someone even gives you the opportunity to ask what gift you want, you can say, I need a laptop or a computer, so that you can use it when we start in January. So this is our last meeting, and I wish you all Merry Christmas in advance and Happy New Year. We will meet in next year. I'm signing off, and I'm handing you over to my boss, Amankwa. So Amankwa, take over. Thank you.
All right, thank you very much, Andy. As Andy said, we plan of doing this program a 6-month program. So actually we are starting January, but then we just wanted to have just some 2 sessions this particular month, and then we begin fully from January. From now, we've started with actual programming. We've learned something called data types. We've learned something called variables. We'll be diving deep and deep and deep and deep. So if you miss a class, I think it's going to be a pain in the ass. So let's try as much as possible to always be online and join our sessions always. The sessions are being recorded. We'll put it on YouTube. So even if you miss class, make sure you go back and listen to it. We'll be putting a lot of materials also in the Google Drive that we shared on the page. We will still share the link again. You can go there and get all the slides and also other materials that we'll be using for the teaching. Even in the holidays, we'll still be sharing some YouTube links and other materials that I think you can just have a look on your own, so that when we meet once again, we can go through. If you have any question, anything, you can just browse us on the page, and we are ready to answer all your questions. Thank you. James, do you have anything to add?
No, please.
Okay, thank you very much. We will meet next year. Merry
Thank
Christmas.
you very much. And we are happy that you guys join and you're interested. See you next year. Stay safe and chill. Enjoy yourself. See you next year.
Don't forget what you've learned too. It's very important because we use it next year. Yeah, that's very much important. All right.
Bye bye.